Okay, so we already did the first problem on this page, and we're going to move down to the second problem on this page. This is another trig substitution. Again, on the test, you would be given what the substitution is. On your homework, you are not. So if you look on that first page, it tells you that if it's in the form x squared plus a squared, then a good substitution is x equals a tangent theta. So what would be a good substitution for us based on that? Perfect. 4 tan theta. You're just looking here, this would be 4 squared, so RA is 4. That's the substitution we're going to want to make. So that's true. We don't have the square root symbol on it, but the substitution still works. That's a good point. Yes, sorry. It would have made more sense. Thank you, Gaddy. It would have made more sense for me to say it was the same substitution for either one. Okay. So let me just go ahead and put that. But yeah, your little sheet suggests either one of those. It would be x equals a tan theta. Good point. Yes, you're going to be substituting for both. And the directions are to integrate with respect to x. So I'm going to go ahead and put the integral and the dx sign. So it looks like that. You're going to need to do two things. You need to find dx and you need to draw a triangle. Okay. So do you remember what the derivative of tangent is? Yes, secant squared. And the other thing that you're going to need to do is go ahead and draw a triangle because you know you're going to need it if you're doing a trig substitution. So if you take your x and solve it for tan theta is x over 4. So you're drawing an angle that represents this. Tangent is a ratio of which two sides? Perfect. Opposite over adjacent. So we're going to put x as opposite and 4 as adjacent. And so we are drawing the angle whose tangent is x over 4. Then you just need to solve. You're always going to need to solve for whatever the unknown side is. You're always going to use Pythagorean theorem to do that. Okay? So if you did Pythag, do you know what it is, or should we write out Pythagorean theorem? No answer, so I'll write it out. X squared plus 4 squared equals c squared, so we're solving for that side. So you'd have x squared plus 16 equals c squared. Take the square root of both sides. So c is just the square root of x squared plus 16. What's that? Oh, sorry. Thank you. Okay, so after you find your use substitution, you find dx, you graph your you draw your triangle, solve for the unknown side. Then you're ready to substitute in. Okay, so we're going to have the integral of 1 over, instead of the x, we're going to put 4 tan theta. Instead of this x, we're going to put 4 tan theta. So if it's 4 tan theta squared, square both parts, what would that give me? Perfect. Is it what? In fact, it pretty much always will. That's going to usually help us. Okay. No, not right now. And then dx, go ahead and put in the 4 secant squared theta d theta. Trig substitution ones are one of the hardest kinds. Does one of those things there look like any of your trig identities? Should I show you some trig identities? That's the one we need to use. 1 plus tangent squared theta equals secant squared theta. So what you're going to do is you're going to factor out the 16. And that would leave you tangent squared theta plus 1. And just again, I'm going to flash this up here. Tangent squared theta plus 1 is secant squared theta. So I'm going to replace this guy with secant squared theta. So now if I rewrite this, I have 1 over 4 tangent theta times 16 secant squared theta. And then this is all multiplied by 4 secant squared theta d theta. That would be very helpful. So let's get rid of the 4 secant squared theta. There's a secant squared theta and a 4. We'll get rid of all that. So let's see what we've got left. Got 1 over 16 tan theta d theta. Any idea how to integrate something with tangent theta in the denominator? Or even what would you do if it was in the numerator? Either way. Do what? 1 over tan theta is cotangent, but I don't really know how to integrate cotangent either unless I make a change to it. It will eventually be a u substitution. Can you break tangent into anything? Sine over cosine is a good idea. Okay, so a couple of ways. It would be cosine over sine, yes. So you could look as 1 over tangent as cotangent theta, if you prefer. And then tangent sine over cosine, so cotangent is cosine over sine. It's a reciprocal function. Or you can say you're dividing by sine over cosine, which is the same as multiplying by cosine over sine. Regardless, this is what you get. Yeah, we can just take it out, since it's just a constant. Okay, now I do think u substitution is a good idea. What do you think u might be? Good. U is sine theta. What does that make du? And we have it. So that's du and that's u. So we're going to do 1/16 the integral of du over u. So that's 1/16 the natural log of the absolute value of u, which is sine theta, plus c. You absolutely do. Okay, so that's why we drew the triangle, because we have our answer, and it's beautiful, but it's in theta. We got to go back and put it in terms of x, because that's what our problem started. So all you have to do is go back to your triangle, and the sine of theta is a ratio of which two sides? Yeah, so the sine of our angle is x over square root of x squared plus 16. So we'll just put that in. Plus c, and we have completed the problem. Okay, so we're going to skip this problem till the very end because it's the hardest, and we're going to go on over to the next page and do this one. Now, I'm not necessarily going to do all trig substitutions. It can be any substitution that you can think of. So if you remember back to that sheet that had like different things to look for to decide your substitutions, this one has an awful lot of ln of x's. And if you'll remember, it says, hey, if you have ln of x, try letting u be ln of x. It's a pretty good way to start. So that's what I'm going to do. We are integrating, so I'm going to go ahead and make this an integral problem. And we'll let u be ln of x. So what's du? Good. Okay, so I'm going to give you just a second. See if you can rewrite this one in terms of all u's. Okay, so most of you are getting the substitution right, but then it requires like another u substitution, and that's where you're getting off a little bit. So the important thing to realize is that basically this 1 over x dx is your du, And so a lot of you got that part. Okay, so if you just take that part and say that's du, then in the numerator you have 4 ln of x, so that's 4u. And in the denominator you have 1 plus ln of x is u squared. Okay, so a lot of you did that. Now when you do this, it almost looks like your ln, because if you let the u be the denominator, 1 plus u squared, the derivative would be 2u, and you have 4u. Okay, you have twice as much as what you need. So you guys are getting it, except you're getting off by the constant. So 2 ways to handle it. You could just take the 4 out, so it's out of your way, and then you need a 2 and a 1/2 on the outside. Or you can separate the 4u du into 2 times 2u du. Which way do you think makes more sense? Okay, then let's take the 4 out. So this would be 4 times u du over 1 plus u squared. And you're doing a u substitution, but you've already got a u, so that's kind of confusing. So pick a letter. Okay, so Q. Okay, the girls don't like Q. What do the girls like? Okay, sorry. Z's. Well, then you write a Q. I'm going to write a Z for the ladies. Well, not if I put that little thing in it. All right, so if we let Z, whatever letter you want, be 1 plus u squared, then dz is 2u du. And you almost have it. You need a 2, and you put a 1/2 on the outside. Okay, so now this looks like 2 times the integral of 2u du is your dz over z. And that's really the only thing y'all were getting wrong for the most part was that constant. Okay, you either have to split it up or take it out. Yep, double substitution. So you have 2 ln of the absolute value of z plus c. And let's go back and see what z is. Z is 1 plus u squared. And you got to put back in the u. And you can do it all at once, that's fine. Okay, so there you go. All right, the next guy looks like this. Let's at least see if we can think of a substitution or something like that. Generally speaking, when you see the double angle, you're going to need a double angle substitution. So be thinking about that. Go to your double angles, see what you can think of to substitute.